Welcome to this video lecture on the topic aperture antennas. So an antenna with an aperture at the end is termed as the aperture antenna. Waveguide is an example of aperture antenna. The edge of the transmission line when terminated with an opening radiates the energy. The term aperture refers to an opening in a closed surface makes it an aperture antenna. The types of aperture antennas are waveguide antennas, horn antenna and slot antenna. The waveguide is capable of radiating the energy when excited at one end and opened at the other end. The radiation in waveguide is greater than a two-wire transmission line. The operational frequency range of the waveguide is around 300 MHz to 300 GHz. This antenna works in UHF and EHF frequency ranges. So limitations of the waveguides. This waveguide with terminated end acts as an antenna, but only a small portion of energy is radiated, while a large portion of it gets reflected back in the open circuit. It means VSWR value increases, so the diffraction around the waveguide provides poor radiation and non-directive radiation pattern. So the radiation of waveguide antenna is poor and the pattern is non-directive, which means it is omnidirectional. So the horn antenna it is used to improve the radiation efficiency and directivity of the beam. The waveguide is provided with an extended aperture to make the abrupt discontinuity of the wave, so that all the energy in the forward direction gets radiated. This can be termed as the flaring. Now this can be done using the horn antenna. The energy of the beam when slowly transform into radiation, the losses are reduced and the focusing of the beam improves. The horn antenna may be considered as a flared out waveguide by which the directivity is improved and the diffraction is reduced. So the advantages are moderate directivity, low standing wave ratio and broad bandwidth and simple construction. So next, the horn antenna is used to transmit the radio waves from a waveguide or metal pipe used to carry the radio waves into space or collect the radio waves into waveguide or for reception. It typically consists of a short length of rectangular or cylindrical metal tube closed at one end, flaring into an open-ended conical or pyramidal shaped horn on the other end. So horns are widely used as antennas at high UHF and microwave frequencies above 300 MHz. These are used as feed antennas or for larger antenna structures such as parabolic antennas. And Huygens principle is used for horn antennas. It states that every point on a wave front may be considered as a source of secondary spherical wavelet which is spread out in the forward direction at the speed of light, a principle by which the actual sources such as antenna and transmitter are replaced by equivalent source. Types of horn antenna: the rectangular horn antenna, circular horn antenna. So these are the main types, and the rectangular has sectoral horn and pyramidal horns. And sectoral horn has the E-plane sectoral horn and H-plane sectoral horn. Let's discuss the sectoral horn and pyramidal horn. So first one, this type of horn antenna flares out only in one direction. So flaring in the direction of electric vector produces the sectoral E-plane horn. Similarly, flaring in the direction of magnetic vector produces the sectoral H-plane horn. Next, the pyramidal horn. This types of horn antenna has flaring on both the sides. If flaring is done on both E and H walls of the rectangular waveguide, then pyramidal horn antenna is produced. And advantages: smaller minor lobes, impedance matching is good, greater directivity, narrower bandwidth, and standing waves are avoided. And disadvantages are designing of flare angle decides the directivity, and flare angle and length of the flare should not be very small. And applications of horn antenna are: it is used as a microwave antenna and feed element for radio astronomy communication dishes and satellite tracking. So another type in the aperture antennas are slot antennas, where a slot antenna is an example of aperture antenna. A rectangular slot is made on the conducting sheet. So these slot antennas can be formed by simply making a cut on the surface where they are mounted on. So the geometry of the slot antenna is given. And the applications are radar navigational purposes and array fed by the waveguide. And assessment questions: which of the following type does horn antenna belongs? So the answer is C, aperture antenna. And which of the following antenna is mainly used for broadband signals? So the answer is B, horn antenna. Thank you for listening this lecture.